HPC 2017 Congress here in Tehran, Iran. I'm delighted to have the opportunity to chair a panel of world experts who will consider a few questions related to the forward-looking directions of HPC and at the same time engage, hopefully, many of you in comments and questions as well that the panel will address. This is a short panel, 45 minutes, and so I will expedite, but I love being up at a podium with a microphone, so I'm not going to just sit down. Okay, that was a joke. Isn't the translator supposed to say he wants you to laugh now? Doesn't that happen? All right. So I think this slide is implicit in all of the discussions over the last 2.5 days, but let me just emphasize a couple of key points which produce the context in which we are considering the next few years. Erwin gave a very interesting presentation this morning describing the European view or look at that. And I challenge you all to understand why he was completely wrong. As one example, and of course Vladimir also pointed out the criticality of worrying about algorithms, and he also got it wrong. So you have rich material from which to be critical and questioning. All right, in my lifetime, it just happened I'm as old as the actual stored program digital electronic computers, plus or minus a few months. In that period of time, from the first machines, which I'll refer to as EDSAC, EDSAC was developed from the earliest vacuum tube technologies with mercury delay lines. From this first, and we'll call it practical machines, to the present, we have exceeded a performance gain of almost over 10 trillion. 10 trillion is a conservative number. There's been no other technology in the history of humankind that has come anywhere near that within orders of magnitude. And yet we're now faced with the flatlining of many of the key factors that have contributed to this steady exponential advancement that we've watched, about a factor of 200 every decade. Moore's law is flatlining. You saw a curve of this from maybe Erwin, was that yours? Okay, but one of the things he got wrong, you may not have noticed, is that he didn't have any data points past 2010. Hey, it's 2017. Okay, so and those points are important because they reinforce his actual conclusion, which is the flatlining of clock rates, power, even Moore's law in future directives, Dennard scaling from architecture, ILP. Instruction level parallelism. When I was the age of some of these students, we had papers from Stanford University telling us how there would be 1,000-way instruction level parallelism. All we had to do is expose it and harness it. You know what the real numbers are? Somewhere between 1/2 and 2. Power has had to flatline. We can't put much more than 150 megawatts into a chip, and even with the chips today, some of that has to be dark silicon. Clock rates, well, IBM continues to push it in the 3 gigahertz range, but at the same time, we have a number of very lightweight cores that operate below 1 gigahertz, and that has not continued. Is that the slowest clock rate that we could, the fastest clock rate we can get? Well, no. A technology that hasn't been advanced or discussed here is superconducting logic, not quantum computing, though it uses quantum effects, but superconducting logic. Clock rate in the lab more than 10 years ago, 700 gigahertz. Why don't we use it? Okay, that perhaps could be the future. Exascale is likely to be achieved, and I mean 1 exaflops LinPack Rmax, is likely to have achieved, as Erwin pointed out in his talk this morning, through a combination of myriad cores and acceleration. You know, in our business, HPC, 5 years from now has already happened. The possibility of influencing the design of the exascale computers is in the details. It's in the engineering. There's no time, there's no opportunity for research, which is a little sad when you think about it. Unfortunately, our field has a major flaw in it. It doesn't think about the next machines until the last machines are done, which means incrementalism dominates the advancement from conventional practices continuously going forward. We don't break with tradition, and this is hurting us. A dramatic shift of the workload with the mixes, and this was demonstrated at this conference, this workshop, includes data analytics and machine learning, but doesn't lose the importance of numeric intensive computation. So now we need future systems that can handle this much broader scope of manipulation, both of number crunching and of data manipulation and transfer. Parallel programming, you may disagree with me, but parallel programming is in disarray, with many distinct and mixed mode frameworks and APIs dominating different sectors. We saw Fortran code up here. Fortran was invented in the late 1950s. Okay, it's improved a little bit. You don't have to do arithmetic if statements anymore, and we don't do blocks the way we used to. But the range of programming methods is ad hoc and patchworks, MPI plus OpenMP, MPI plus OpenMP plus CUDA. Do you really think this is a well thought out approach to computing? People say, we don't want to change. And then they answer, and this is how we're going to change. Maybe time for a change. It is, however, and I hope many of you have captured this notion, it is an exciting time, truly exciting time to be a practitioner in HPC systems, development, and applications. I'm glad I lived long enough. The last time we were here was in the 1980s. There were many different classes of systems. And then somebody invented commodity clusters, and it's been the same old for the last 20 years. So I'd like to ask our panelists, if they will, we'll start at to my immediate right, to just quickly identify themselves, where they are, and just a one-sentence statement of their field. Okay, you can take my microphone. It's all right. Okay.
Yes. Thank you, Professor. I'm Mohamed Eshki. I'm working on high-performance CPUs as an ASIP, application-specific instruction set processors, working on a parallel processing and something like this.
Thank you. I'm Vladimir Voevodin from Moscow State University. I think I'm in high-performance computing and parallel computing since the middle of the 80s, and my scientific interest somewhere between problems, mathematics, and hardware. Most exactly, I would say, the most interesting and exciting thing for me is the supercomputing co-design technology, as well as different educational issues in this area.
Erwin Laure from KTH, the Royal Institute of Technology in Stockholm in Sweden. And yeah, I'm also working on high performance computing with a focus on programming environments and tools. And I'm also working a lot with applications in a co-design fashion, see how they can reach the exascale.
I'm Valerio Pascucci. I'm a director of the Center for Extreme Data Management, Analysis and Visualization. My major focus in data analysis and exploration, and through large data, I've been practicing some high-performance computing techniques. Although I don't feel like I'm an expert in that, I'm more learning than teaching those in this field. But certainly, the data movements have become a major problem in HPC, and that's where my focus is at the moment.
Panelists, thank you very much. Now, I'm about to, on one slide, present your charter. I'm sorry for the inconvenience that the image is directly behind you, so everyone will turn around and stretch the backs. So these are the questions to the panelists. They're really one question combined in different layers. They all go in one direction. So I'm not going to ask the panelists to respond to each question explicitly, but rather from the sense of the intent of the questions to project their own opinions and their views about the future. So the first question is the highest level, and I would like to get from the panelists each the idea of what the biggest technical challenge we face. And we've had a number of comments in the last 2 days, but what is the biggest technical challenge we face to advancing high-performance computing, not in the next 5 years, that's preordained, but beyond that, to the range, the performance range of XOps capability, both for numeric and big data. Then within that broad scope, charter and goal, we recognize that we are at the end of Moore's Law, as I had said, and so within that, coming that we're in a very different place than we've been for the last 30 to 50 years in how we get advanced computing capabilities, what areas of new strategies, and there are many different areas, technology, architecture, programming, whole paradigm shifts, if you want to talk about quantum computing, what strategic areas will drive the future of HPC? And it may not be any single one. Panelists, on what do you expect to rely from other research environments, industry, and nations to succeed in your future HPC enterprises? What do you need from others? And conversely, in what areas would you expect your community, it can be your university, your industry company, your nation, in what areas would you expect your community to make substantive contributions to this global, and it is truly global, let there be no misunderstanding about this, to this global goal? And finally, you personally, as individuals, how would you like to personally influence, guide, contribute, or employ future HPC systems in the 2020s and beyond? So with that, I'm going to ask the panelists. Let's start to my far right. Yeah, you're first.
Ouch.
Well, you have a microphone, so
Yes.
Okay. And please, don't take any longer than a half an hour.
Okay.
And that's true for each of you. So we'll get out of here before midnight.
Okay. So no, I'll try to be brief on this. So technological challenges in the future. My easy answer is that as data movement is a problem now, any expectation is that that will be increasingly a problem in the future. I mean, there is clearly a trend, or in some sense, a flatlining of data communication, while data generated is larger and so on. So from that perspective, I see anything that will contribute to moving data, network technology, but also theoretically algorithms that reduce data movements is going to be a key direction for the future. So end of Moore's law. That's a very interesting question. I mean, clearly Moore's law has been, first of all, it's not really a law, but that can be discussed in a different environment. But I'm actually a little bit optimistic in the sense that, Moore's law has been sustained by the continued kind of reinvention of how things are being done. And in some sense, parallel computing is part of that shift from just increasing clocks and density to high concurrency. And that's kind of how pseudo Moore's law has been sustained in the last few years. In my view, I think if we really want to look long term, there must be a shift out of the current chip approach. And yeah, quantum computing looks like one. I actually suspect that kind of biological systems are going to be more practical, although they're going to be much more difficult. I mean, the human brain is a great example. We have no idea how that works in practice and so on, but those are actually biological systems are the ones that are really low power, high density, and long term, somehow I think that's where we're going to go. I'm not going to be part of that because it's so far out of my expertise that can be only a dream. So in terms of contributions, expected contribution or desired contribution, so I actually think that more than the technology question, and to some degree I disagree with the structure of the panel in terms a lot of the questions are really focused on the technology pieces and therefore are intrinsically short-sighted. I think we should look at how HPC and this advanced technology connect to economy and society, because those are the things that will actually sustain the growth, the shift in technology and so on. We really have to make a strong conscious effort beyond our, say, computer science expertise and see where this help medicine, biology, energy sources and so on. Effectively, the only thing that will really help our field make progress is to show value to society, especially because it's an extremely expensive endeavor. I mean, you have the machines that use the most power in the world and so on, and they are even more power hungry. I think we will need, as a community, to keep pushing the economic case and the society case for the need of this technology and the future advances.
Well, I apologize for my short-sighted view of and lack of forward-looking. I appreciate your candor in this, and I'll get you back later. Erwin.
Yeah, I'd like to echo the previous speaker. I think, Thomas, you gave a very good introduction, but you have produced the wrong questions out of this introduction, and so I choose to answer a different question that is not on the slides. And I think you made a very good observation that we are stuck in our own hole. We are making only incremental advances. We have not managed in the whole history of parallel computing to make really disruptive changes. As we've seen, and as Vladimir has pointed out, right, we started with vectorization, we added shared memory, we added distributed memory, we went back to shared memory, we added accelerators, now we will be adding FPGAs, now we will be adding compute and storage, compute and network, but we're not making any fundamental changes. And we need to really think, why is this the case and how can we change this? Well, one reason clearly is that those who are leading today, who have the leading applications today, they want to have the leading applications tomorrow. So they cannot embark on a project that will take 10 years and has a high risk of failure and leave their current code unattended. So by nature, they will do incremental changes to keep up with the next generation of hardware, which is coming out every 6-12 months. So we need to find a finance basis, a funding basis that allows these people to keep doing incremental changes and at the same time embark on crazy, forward-looking, disruptive projects that have nothing to do with incremental changes. Way too often we sell our incremental changes as disruptive changes. We need to make a hold on that and say, no, this is really incremental, disruptive is something else. But that also means we need also to change the way we think of science. We are somehow stuck in a curse of success. Everything has to be successful. And that's why we have incremental changes, because then I can predict, yes, I'll add my OpenCL, I'll add my OpenMP, something will come out. Yeah? I will have a successful project. We need to allow projects to fail. We need to develop a culture of failure that allows us to fail and we get recognition for the work we've done, even if at the end it was a dead end and it was not something that we lead forward. But we gained knowledge through this. I think in our community, we have not developed this culture, and that needs to come.
Thank you very much. I'll give you the mic.
Thank you, Thomas. I'm sorry, it seems to me that I forget initial question, but let me... Yes. What kind of challenges we will have after exascale? I think that this is a very serious question, but it depends, first of all, on the physical effects that we discover that can be used as the basis for the future computers, definitely. It could be quantum computers, yes, it's very promising direction. It could be some kind of biological computing. It could be neuromorphic computing. Now we can guess, but I believe that we'll reach exaflop, exascale level by means of the current technologies. And what we will have in 5 years, I think very soon we will have FPGA technology integrated on a chip, and in this case it will be very serious problems for applications, for scientists, how to use it. In some sense, in some cases, it will be quite easy if you will have this vertical line started with a package like, for example, cafe. It is designed right now designed to be able to use FPGA technology. And if I use cafe package, cafe library for deep learning, for data analysis, it doesn't matter for me what is at the basis. I think during exascale, at the current technology, we will use a lot of different accelerators. If it's true, I mean, about FPGA, about a lot of accelerators, the main problem we will have during exascale, it's a problem of complexity, it's a problem of a huge resource of parallelism that we need to use somehow. Somehow, I don't know how we will use it. I hope there will be a lot of different software, specific software packages that will hide all this complexity, all these problems inside that will be managed by professionals who design this software, this pieces of software, and I will solve my problem again in physics, biology, astronomy, bioinformatics, and so on and so on. Complexity and the huge level of parallelism are main challenges that we are facing now. And it's a serious problem that we will have in 5 years. What will be beyond exascale? As I said before, it depends very much on the physical discoveries that will be done in the nearest future. Quantum computing, neuromorphic, bio, and so on and so on. We'll see. If we will have quantum computing, we will have special algorithms to be able to run efficiently on this kind of hardware. If we will have neuromorphic computing, we will have to have special algorithm to be run on this hardware. We'll see.
Thank you. Oh, very hard questions. I'm going to answer maybe very short to two of these questions. One is our nation, what contribute our nation, our community. I think because algorithm is made in this country by Mr. Kharazmi, and his name goes to the algorithm, and I think the bottleneck of all this HPC still stands at the algorithm. I think we can contribute very good in making parallel algorithm for different application. Now we are working on many algorithms in different areas to build to design a hardware for that algorithm, especially in ASIC design, ASIC processor, application-specific instruction set processor. And I think in the future, with this kind of processor, some more expert processor than just simple processor, which now has in HPC computers, millions of them, but they have problem dealing with the algorithm. So in the next part, I think the bottleneck of HPC would be simple processors, of course, with many of them, but still they are simple. So the processors should be more complicated, and then a computer, a supercomputer with 1 million of these processors can better work on the algorithm in different way.
Well, thank you all very much. I have to say that the panelists have performed far above my expectations. I don't know about you, except for, of course, their malicious comments towards me personally. But I think this was extremely useful, and it may not be, due to their own real intelligence, but whatever they spouted made a lot of sense. Now, this is my first time in Iran, and I do not know the Iranian culture. If we were in Western Europe, or we were in the US, or we were in Canada, you would all be shouting right now, and you would be bullying and maybe throwing some things or paper airplanes, because you realize that we're all too old, far older than the average here, and we've got it wrong, right? Now, and I think I could say this without getting into too much trouble, if we were in Japan, you would all be sitting there absolutely silently, just praying that we would end very, very quickly, and not wanting to stick their head out because one of their older bosses is somewhere in the room, and they would defer to authority. If there's one thing I assure you, in high-performance computing, never defer to authority, because authority is wrong. They made all the mistakes, and your generation has to fix it. So I'm now asking, begging, pleading, please, either comments or questions, preferably no advertising. We open the floor to the audience. Sir. And do we have somebody running around with a microphone? Hello? Sterling to Earth.
The problem is we have only one wireless microphone right now.
We have only one wireless microphone. Okay.
And you have it.
So you want me to run around?
Please give this.
Maybe let's.
Okay, so I'll shout and point. I think that's all I have to do.
I would like to start with this joke, if it is, that says, okay, there is a law about Moore's law, that the number of people who predict the death of Moore's law doubles every 2 years. And, but we're still going on. But my real question is, we have a real challenge in high-performance computing, which is code portability, and we fail to address this problem. We fail to address the problem of having proper tools. Moving our code from one machine to another platform is a real pain for scientists. This is one problem. And the other problem that I think is a challenge is the fact that we would like to continue to rely on human brains, human resources. I don't think it works. Just take this example, that scientists who are not expert in computer programming, they are responsible to develop algorithms. And now we are trying to put more burden on their shoulder to make it easier for programming. Is it possible? I don't think so. We need to, perhaps we need to use machine power, maybe if artificial intelligence is something true, to develop better tools to make it more efficient for future HPCs.
Thank you very much. Oh, wow. Okay, so if I may summarize, and correct me if I'm wrong, the issue is a combination of user productivity and performance portability. A question you're asking is the validity of advanced tools and possible. And just one small point, you brought up the human brain. I wouldn't do that. It's way over exaggerated. We don't want the computer to be as good as the human brain. We need it to be much better. All right, so I think the question here is the key efficiency of people using machines. I believe that was reflected by a number of the comments. And let's start from this end, and I'd ask the speakers to comment on the issues of productivity and performance portability.
Well, I don't have any idea.
You're the only honest one here.
Sorry, I have some ideas. In In principle, you're right. And developing software, any kind of software, you have to find a compromise between efficiency, portability, and productivity. If you want to make it fast, you select productivity. If you're thinking about different generation of computers, you select portability, and this is very important for you. Right now, there is no choice. It's your decision, and you need to make this choice. What kind of solution you have to select between efficiency, portability, and productivity? Yes, sometimes it's a difficult choice. Sometimes you are happy and you have wonderful solution. For example, if you have specific package or library, you have to think in terms of your specific subject-oriented area in, again, biology, chemistry. You don't need to know anything below this point. You just use this package to solve your problem. But this is not general situation. I believe in the future the number of these packages and this software infrastructure should be very rich. Even, especially for you to be able to solve efficiently your problem on any kind of hardware. It doesn't matter for you what kind of hardware underlies these software packages. I believe that in the future this software infrastructure will be rich enough to satisfy many users for different software. And this problem of solution between productivity, portability, and efficiency will be solved in this way.
So, yeah, that's okay. I think we need to go back to the economy, and particularly when it comes to draw the line between usability and efficiency. If I save one person year, right, in writing the code because I have a very usable and quick, productive framework, but at the end my code is 10% slower, what will cost me more, right? I think particularly when you go to the exascale and have codes that run frequently and use a lot of CPU hours, spend more time in optimizing them. So we need to work on the usability, but we must not forget the efficiency. And I'm afraid that if we just focus on the very nice programming frameworks, they're all good and nice, but at the end somebody needs to go down to the nitty-gritty details and fix them. My second comment is on artificial intelligence. And here I'm quite skeptical because we know that humans are not intelligent and make stupid decisions. I'm not sure that an artificial system devised by humans will be any more intelligent. I'm going back to the problem we had before. We need disruptive solutions. Right? We are stuck on the algorithmic complexity trying to reduce flops. Maybe that's not the goal, right? But we need to analyze that. And I don't think artificial intelligence will help us there because artificial intelligence will just point us more in the direction where we already are. But I might be wrong. I'm not an expert in artificial intelligence.
Yeah, so I have my private microphone so I can talk more. So I think, first of all, those are very good points in terms of the pain point of users of the technology. There is definitely trends like domain-specific languages and so on that try to help productivity. And I think actually people like us that develop the technology probably have to learn to be more comfortable with the code being 1% efficient, but very productive in terms of humans instead of being obsessed to achieve 80, 90%, because that might not be the value that you bring to people. In general, I look at this also from other fields. The question is really how do we build different level of abstractions so that people work at the level that they need to. If someone is not an expert computer scientist, they might build a code that is not super efficient but gets the job done in a reasonable amount of time. And in industry, the concept of good enough is always used, and the perfect is enemy of the good enough, but that's how you make progress in many cases. So I think actually there are some trends that are going in the right direction. Regarding machine intelligence, while I'm not an expert, so I think the bad combination of being a computer scientist and not an AI expert make things skeptical. But so I am too. But for example, if I was looking at chess, and Kasparov actually started showing that teams of machines and people are much stronger than people alone or machine alone. And I think looking long term, I think we should look and try and embrace that type of concept, and not thinking of one replacing on the other, but say what is going to be the right level of partnerships, because machine intelligence is probably going to emerge. The issue is that it's going to be very different than we are. It's never going to be super fast in certain things. Maybe it's less creativity or whatever, but I think that the diversity will be the key, and I think partnership is going to be the winning strategy for the future.
All right, well, thank you very much. The answer to your question is concurrence. The problem you've observed is real. We have solutions from the point of we don't have a clue, which is probably the right answer, to focus on specific domains, machine intelligence, and well, more machine intelligence. My personal view, and I'm sure you all care, is that by the year 2100, computers will be laughing at us and at the notion that humans tried to program computers. When, of course, it's the computers that program us. Just try to use your GPS. Who's the master and who's the slave, right? All right, can I have another equally inspiring and motivational question, please? Young lady. No, not you, right.
Thank you. I should confess I'm scared of this HPC because it's kind of revolution. It's a new lifestyle for human being, and I wonder if our lifestyle and human lifestyle is so dependent on the machine, and what's going to happen to us? Is it our life is going to be easier or more complicated? I don't know what helped me to.
Okay, so that is the deep question, which the rest of us didn't have the courage or insight to ask, and you pinned it. Thank you very much. So, panelists, what we're asking you is, what is the meaning of life, the universe, and everything?
And all that.
And I don't want to hear 42. As associated with the implications. This is the deep question. No, seriously, we could have been sitting here 250 years ago and talking about steam locomotives and asking the same question, or how steam power would be affecting, well, the whole notion of mass production in factories. Indeed, society, do we define society, or does society and our technology define us? This is scary. Okay, this time you can't get away with I don't know.
Well, I think we already are controlled by computers. It's not going to be for the next 100 years or 2100. Right now, many decisions we got comes from computers, from programs. The stock market changes to the news in the newspaper, so they give us some clue to buy something, to sell something. I think it's not as scary, because all the time I believe still that we program the computers because we created this. So it's not going to be as scary. As Professor said, maybe 200 years ago we are scared of steam power. Right now we just passed this time. I think human being is going to get stronger, stronger. They said usual people uses 3 to 5% of their brain about 100 years ago, and now it's about 12%. Einstein uses 15%. So maybe we should use more brain to challenge this computer, HPC computers of the next generation. So it's not scary at all.
Thank you. Will it be dangerous in the future or not? Should we scare or not? Definitely this kind of technology are very useful for us, and it's not necessary to explain why. At the same time, for example, when I watch TV or when I'm in the cinema, I do not understand exactly is it a human on the screen or it's a computer-generated image. Very often there is no difference between this sense in the movie and in a few years there could be, now there are a few examples, maybe not of very good quality, but in the future there will be completely computer-generated movie with the natural sense, and computers are everywhere. Should we scare or not? I believe right now we try to understand the structure of human brain. Is it dangerous or not? We need to do that because there are a lot of diseases. We need to struggle with them. At the same time, how can we impact human brain? What we can change, what we cannot change. It doesn't matter for what reason. This is a very serious question, but I would say this is a, first of all, question of education, of deep education, and this education should be a very balanced combination of education in natural science and humanitarian science. Only this combination will be the best one, and in this combination, in this good combination, it will be safe future. I believe in so.
I also think, well, it's not a question whether this change will influence us. It is already influencing us. There is influences that we probably all agree that are good, that we can produce better materials, more efficient cars, better airplanes, better water distribution system, better traffic system, whatever, right? I think that's probably non-controversial. Where the controversial thing comes is when computers start to program us, as Thomas has said. And this is not in 200 years, this is today. The computer tells you which news to read. The computer tells you what restaurant you should choose. The computer tells you where to go. It's quite often wrong still, but this is what is happening. And whether this is good or bad, I don't know. That's a deep philosophical question that I can't answer. But the technology is there and technology will not stop. So we better adopt to that style.
Okay. So yeah, so I think that obviously this is a very deep, important question. And of course, it can be easily look at what would happen right now if electricity goes away, right? It's like, yeah, we would now have light in the room, there would be no microphone, and most of all the people working on their cell phone would have to pay attention. So that would be a catastrophe. But generally, the reality is that it's actually, I think, good that people have some fear of those things, because that's what will make sure that the technology will go in the right direction, that this concern will push us to try and go in the right direction. Obviously, it's not guaranteed. But practically, people are, well, the way you say, voting with their feet. I mean, when the technology is available, they use it, and therefore it's going to be adopted and will grow. There's going to be a market for that. And I'm sure with my grandchildren, when I will tell them I was driving my car myself, they will say, "Are you crazy? How many people you were going to kill with that?" Right? It's certain things are, we almost forget how good they are, how much better they are than we are. But in some ways, obviously, we will actually be weaker and more dependent on that. And But even today, I mean, if we had to go back hunting, obviously, I would be in trouble, and many people would be. But I mean, who would honestly dream of a society where that's actually what you want to do? So even looking now in agriculture, the smaller fraction of the population is doing it, and we're working on technology that will shrink the number even more, and then we'll have drones and machines doing all the agricultural work. And the reality is that because people want to leave the farms, they want to go in a city and have what they think of that a better life. So in some sense, that answers the question directly, and people answer it just by their behavior. So I think it will be great and beautiful, but it's good to be fearful of that.
Well, so I'm standing here thinking about this very important question, and I'm imagining, projecting, suppose we weren't here now, and not even 200 years ago, but 1,000,000 years ago. And here we were, a room full of Homo erectus, being asked, what do they think of this new idea of Homo sapien, and how is it going to affect them? Unfortunately, we can't ask Homo erectus, because they're gone. I don't want to scare you. So, I know you're really wondering what the answers to these questions are. I will give you the correct answers. In order from 1 to 5, they are no, no, yes, no, maybe. Please join with me in thanking the panelists for what I think was a very interesting discussion. This is where you applaud. Let me conclude by thanking the organizers and all of the participants for what has been a very, not just interesting, but enjoyable 2.5 days. I've had a delightful time. I know many of my colleagues have. And now if I can actually find someone who's leading this meeting, I will turn the microphone back to them. Nobody's getting up. Did all the chairs leave? Well, then I am in control. And with that, I will finally say thank you all very much. This concludes Top HPC 2017, and please join us for the cocktail party? The cocktail party, I believe it's next door. Is that right? Yes. Thank you all.
دوستان اگر جمع بشن این جلو و عکاس هم زحمتش بکشن بیان بالا، فکر میکنم یه عکس دست جمعی با کلیه دوستان بتونیم داشته باشیم. همین جلو وایسیم، هر چقدر میشم فشرده تر. از آقای دکترم خواهش میکنم دوربینشون رو بیارن این بالا تا جایی که میشه ببرم بالا. بله نه خانم دکتر از بالا خوب دیده میشه. خانم دکتر از بالا تقریبا همه دیده میشن، یک کم باید بره بالاتر فقط.